Hey everybody, in this video we are going to find the exact value of the tan or tangent of 7 pi over 12. However, there is a part 1 to this particular problem, and in part 1 we solved using kind of like a panic mode if you only remembered the rules for sine and cosine, and then basically did sine over cosine as tangent. In this part 2 video, we are going to use the actual tangent rule. Also, it should be noted that, as above my head, this is part of a unit, where we find where we use the angle sum and difference identities. So we will be applying those in order to do this problem. This could be done, however, using the half angle identity if you've gotten to that, but that's not where we are right now. Dallas wants to be involved, I suppose. He's ready for bed with his pajamas today, so hopefully he's not too annoying during this problem. All right, so let's dive in. I'm still going to use alpha and beta as pi over 4 and pi over 3. Also, if you didn't watch part 1, maybe watch that one first, because I might say or do things referencing stuff in part 1, and I will link it in the description below. Alpha is pi over 4, beta is pi over 3. When I write them with the common denominator of 12, we clearly see 3 pi over 12, 4 pi over 12, which as we add them, we find their sum, we get 7 pi over 12. So that being said, I just don't want to make sure I don't go off the screen. I tend to do that sometimes. So we have, so tan or tangent of alpha plus beta, and you want to have these memorized. That will be, and you do not distribute tan. However, the way I memorized this when I was in high school, and I still kind of do now, is I pretend, it's not a thing, I pretend I distribute tan when I do the top. And then on bottom, 1 minus the product of the two parts on top. So another thing that kind of ties in is that I remember tan is sine over cosine. So the top sine keeps the same sign. So if that's plus, that's plus. Over cosine, and the C cosines, O opposite signs, but at least the opposite part, the middle of cosine is that O for opposite, sine keeps the same sign. Kind of helps you remember the rule, I hope, if that was helpful. If not, thumbs down. So from here, we need to approach this slightly differently than before, where I need to know tan of alpha, tan of beta. So I'm just going to do that on the side. Tan of alpha is the same as saying, let's find the tan of pi over 4. And the tangent of pi over 4, I hope we all know, is 1. And then tan of beta, pi over 3, it's the same as finding tan of pi over 3. And that will equal root 3. If you don't know those things, then I would refer you back to Tan the Meditating Man video and work on memorizing them, whatever it takes, okay? So let's go ahead and start filling in now that we are evaluating. So next up, tan of pi over 4 plus pi over 3 equals, relax bud, tan of pi over 4 plus tan of pi over 3 all over, sorry if my hand's in the way, I'm trying to do 10 things at once, 1 minus the product of those parts, tan of pi over 4 and tan pi over 3. Don't try to be a hero and start filling random things in. So next, tan of pi over 4 plus pi over 3, well, that is where we get 7 pi over 12. I promise. How do we know? We have the side details right over here. Then we get 1 plus root 3 over 1 minus 1 times root 3. I could write it like that. That 1 isn't really necessary out front, right? We could just scribble that guy out. He's invisible. Now, again, another reason why you should be watching part 1 first. Before this, I really went into detail explaining what we do to rationalize our denominator. We are going to multiply, because we're not allowed to have a radical on bottom, by the conjugate of the denominator in our denominator and in our numerator, because you are only allowed to multiply by the multiplicative identity, which is 1. Otherwise, you change the value of the expression. On the numerator, we're going to multiply. We're going to use the mnemonic device FOIL. The outer and the inner do not cancel out, clear out, anything like that. Just go carefully. But on the denominator, because they are conjugates, your outer and your inner terms from FOIL will cancel out. So tan of 7 pi over 12 equals, all right, first is 1. Outer is plus root 3. Inner is also plus root 3. This will equal 2 root 3 plus root 3 times root 3. You should know that. Don't put root 9. It's too many steps. You don't need to do that anymore. On the bottom, I like to do the longer one first typically, because the bottom will be the first term and then the negative last term. Okay? 1 and 3, I get 4. Root 3 and root 3. Please don't do anything weird here. Please. It's like banana plus banana. 2 banana. Right? Root 3 plus root 3 is 2 root 3. Okay? Over negative 2. Now, just to go in a bit of detail, showing this simplify, we also spoke about negatives not being allowed on bottom, so I'm going to pull it first in front of that fraction bar. I'm also going to factor a 2 out, my greatest common factor, and that leaves me with a 2 plus root 3 over 2. This 2 and this 2 reduced down to a 1. Then the negative is left. I could either write this as negative 2 plus square root 3 in parentheses like that, or I could distribute that negative and I can write this as negative 2 minus square root 3. Either answer is good. Both are acceptable, but it's important that if you ever have a multiple choice test or quiz or something like that, that you can identify, maybe you found the answer like this, you need to be able to identify that that is also correct. Or sometimes they like those questions where you could check off like, oh, this is right, and then like a choice might say both Roman numeral 1 and 3 are correct. All 3 are correct, none are correct. So read all the choices, read carefully, but that right there was evaluating and finding the exact value of sine, tangent, 7 pi over 12, using the rule we have for the tangent angle sum identity. We just showed that we got the same answer as if we had done it with sine over cosine. I think this was a little bit nicer, a little bit less messy than part 1. Than, I should say that more properly, not then and than are different words. Sorry, my accent sometimes. Yeah, any questions, let me know. I hope that you realize, the pros and cons to each. One might be easier to remember, but one is a little cleaner and neater to take care of. Anytime I could avoid pi over 6 with tan and just use pi over 3, I tend to do that because pi over 6 is root 3 over 3. There's more fractions, compound fractions, yada, yada, yada. So if you understand or if you got this right, thumbs up. And if you don't understand or you got this wrong, thumbs down for me. Let me know so I know what to do to help you do better next time. Okay? See you in the next video.